Catalysts are a class of materials that help facilitate and improve the outcomes of chemical reactions. They are vital in many of the processes industrially that are involved in procuring the commodity chemicals and pharmaceuticals that we rely on every single day. These reactions, however, only occur on the surfaces of these catalysts. Therefore, if you have two bulk identical catalysts, the one with a higher surface area is going to be more efficient at doing its job than the one with lower surface area. Much effort has been put into developing research to improve the surface area of catalysts because of a very simple relationship. Increasing surface area means increasing your production and process efficiency, which means increasing profitability. However, many industrial catalysts have a problem. They're either hard to reliably create, expensive, or have some toxicity profile. Magnesium oxide, on the other hand, has a very good safety profile, is incredibly abundant and incredibly cheap, and catalytically active. However, it's rarely used in the chemical industry because of its one fatal flaw. It has terribly low intrinsic surface area. Therefore, if we're going to enable magnesium oxide as a safe and effective and cheap alternative catalyst, we need to find ways to increase its surface area. And this is where our work comes in. We decided to look at metal organic frameworks, or MOFs, to procure high surface area metal oxides. And the reasoning is because these metal organic frameworks themselves have very, very high intrinsic surface area. And they're classified by having metal oxide clusters, such as magnesium oxide, contained within a carbon backbone. It looks complicated, but that's really all it is. And we had this idea: if we take a high surface area precursor, such as this MOF material, and simply heat it up and burn off the carbon backbone, we might be left with a high surface area resultant pure metal oxide. And that's exactly what we did. We took Mg-MOF-74, a magnesium oxide containing metal organic framework, and heated it up. And we created a high surface area magnesium oxide, tested it against its conventional counterpart, and found that it had a 32-fold increase in surface area and improved catalytic efficiency. This research thereby shows the promising route for MOFs to be used to procure high surface area metal oxides as sustainable and effective and cheap catalysts to replace our current ones in the industries that produce the chemicals and commodities that we're interested in. Thank you.